Folks, I want to start off with a review of logarithms, so let's go ahead and get started. As always with these reviews, I don't think I'll be able to cover everything about the topic, but hopefully it's enough to get some of your questions answered, and if you have others, just let me know. So I want to let's go back to the definition of a logarithm. So let's suppose we have a statement such as a to the nth power equals m. Then we're going to define the log base a of m to be the value n. So this looks kind of, there's a lot of symbols here. But this is truly the expression that, until you get comfortable with logarithms, it's what allows you to convert them back and forth between exponents and logarithms. So it's a critical expression to make sure you have understood. Let me just highlight a couple things. One is this is still called the base of the exponent. That's what we've always called it. That's the base. This is called the base of the logarithm. And notice that in the exponential statement and in the logarithmic statement, the bases are the same. The next thing is to know that when we take the log of a expression, it returns a power. Notice that this was the power that a was raised to give us the expression m. So when I take log base a of m, it returns that power. I think it's easiest to see this by way of an example, so let's do that right off the bat. We have this fact that 2 to the 5th power is equal to 32, so therefore, what is the log base 2 of the value 32? And the answer is the log base 2 of 32 is equal to 5. Okay. So I'd like to do the rest of this in terms of the natural log function. So recall that if we were looking at the function f of x equals e to the x, let's say a few things about it. Well, first of all, the domain of this function went from minus infinity to infinity, and the range went from 0 to infinity. Also keep in mind, like all exponential functions, when we evaluated at 0, we just got 1. Let me expand that just a little bit. We got e to the 0th power, but for any exponential function, when we raise it to the 0th power, we get 1. So these are some facts that I assume that you should have readily available to you. You should be able to pull those up as needed. So if we go ahead and graph the exponential function, remember that it passes through, we just said it passes through the ordered pair 0, 1. So there's right there, pair 0, 1. And then the graph of it looks like this. It's not a perfect graph, but it'll do. Here's the graph of e to the x. And notice, notice that we have a horizontal asymptote at y equals 0. Okay, so working with logarithms is much easier the more you can remember about the traditional exponential function. So the next thing I want to say is that for f of x equals its inverse function is, let's give it a new name, let's just call it g of x. Which is the inverse function, and that is the natural log of x. So remember that this is red, natural log. Okay. So if we wanted to graph both f of x and its inverse, okay, I've just graphed this just a moment ago, but let me put it up here again. So here's the graph of e to the x. It always passes through the point 0, 1. And we have this horizontal asymptote at y equals 0. Well, its inverse function is the natural log function. And because of the way we define an inverse, we ask it to give an inputted range value, it will return the original domain value. So this passes through the ordered pair, what? It passes through the ordered pair 1, 0. Likewise, where the exponential function had a horizontal asymptote at the equation y equals 0, the natural log function will have vertical asymptote at the line x equals 0. And then if you just follow that corresponding relationship between the domain and range of a function and its inverse, they all get reflected about the line y equals x. I'm reviewing this topic very quickly, but here would be then the graph of the natural log of x. Okay, let me it's not quite how I want to write it. Let me just stretch that out just a little bit more like that. Okay, so there's the graph of the natural log of x. Notice that they are symmetric about the line y equals x. And we can observe a lot just by knowing the graph. So this is going to be very helpful. So I expect that you can always just quickly graph e to the x and then quickly graph the natural log of x and be able to ascertain these facts, where the vertical asymptotes / horizontal asymptote and what points do both these functions always pass through. Okay, I think that's all I want to say as an introduction to these. So we'll just stop there.